All right, so for section 8.3, arithmetic series part A, this is supposed to be the easier of the two. The other one is not that it's more difficult. Like I said, it just has some notation that they use that looks like it's difficult, but it really isn't. You just got to understand what the notation means. But we started talking about sequences being just a list of terms separated by commas. So I gave two examples there, like 1, 2, 3, and 4, or negative 2, 0, 2, and 4. And then we talked about what a series is, and a series is just adding up the sequence, right? The sum of a sequence. So just putting a plus in between the numbers instead of commas. That creates a series, okay? So you're adding them, okay? So series is addition of a sequence. That's all it is, all right? Now, for today's homework, what they're going to be asking you guys is to find the sum of an arithmetic series. So in other words, they're going to say, hey, I added the numbers 1 plus 2 plus 3 plus 4 plus 5, etc. What would it come out to if I added 100 terms? Right? So 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100. You add every single number in between from 1 to 100. What does it add up to? Right? So in order to do that, we use formulas. Okay? This is one of them. We have this formula here. We also have an alternate form depending on what you're given. But we're going to start off with the original one. The sum of an arithmetic series, S sub n is equal to n over 2 times a sub 1 plus a sub n. Now, n is the term you want to add up to. Okay, so if I said S sub 7, that means I want to add up 7 terms. Okay, so let's say I put S sub 5. I'm saying add first 5 terms. So S sub 10 means add the first 10 terms. S sub 3 means add the first 3 terms. Okay? So n tells you the term you want to add up to. So if they put S sub 200, that means I'm adding the first 200 terms. Okay? So that's what n is, the term they want you to add up to. A sub 1, we should know that already. That's the first term. Bless you. Okay? And a sub n, they call that the nth term. Now, a sub n depends on what the n value is, right? So if they want me to add up the first 10 terms, so if n is 10, then we'd have a sub 10, right? So depending on what n is, that gives a definition for a sub n. Okay, so if n is 7, then we're going to go all the way to a sub 7. If n is 100, we're going to go to a sub 100, all right? So this isn't difficult as long as they give us the required information. So you're going to kind of see right now what these problems look like. So make sure you guys keep that formula kind of somewhere where you can see it. I'll rewrite it again, but when you're doing your homework, keep it somewhere where you see it because you're going to want to use it. So we're going to do example 1, part A and B, and then we're going to move over to the alternate form. Like, what if they don't give us everything we need? Maybe we can find stuff using the series and figure out pieces that we can use to add up those things. But for now, they're going to give us everything we need. Okay? So for example 1 says evaluate the arithmetic series. In other words, find the sum. Okay? So figure out the sum of this arithmetic series. Now notice, in part A, they said, look, the first term is 12. And a sub n is 40, but n is 5. That means that the fifth term is 40, right? A sub 5 is 40. And they say add up the first 5 terms. So you're going to start with 12. You're going to end with 40. And in between, there's 3 more terms because they're saying you're going to add up 5 terms. A sub 1 is the first one. A sub 5, 40, is the last one. That's 2 of them. They want you to add up 5 of them. That means there's 3 more terms in the middle that have to be added together to find the sum. Now, I don't want to go through the trouble of figuring out, like, okay, the first term is this, and the second term is that, and the third term is this, and the fourth term is this, and the last one is 40. We could do that because we actually did that when we went over sections 8.1 and 8.2. But with the formula, we don't have to. We don't have to figure out what numbers are missing. We just need to know the first term, the term they want me to add up to, and that's it. So They told me to add up to 5 terms. So I'm going to put, well, let me write the formula really quick, just so you can see it. S sub n is equal to n over 2, a sub 1 plus a sub n. Now, we know that n is 5, so we're going to add the first 5 terms. Okay? Now, n is 5 over 2. A sub 1 is 12 plus a sub 5, right? That's my a sub n part. That's 40. So this comes out to 5 over 2. This is 52. 52 divided by 2 is 26. That's 5 times 26. And what's 26 times 5? We have 30, so 130. And there's your sum. The sum of the first 5 terms. So whatever numbers are in between 12 and 40, if I add up those 5 terms total, they'll add up to 130. Okay, so you see the formula is not that hard to use as long as they give you the pieces you need, right? So let's check out this next part. This is the same thing. They're going to give you the first term. They're going to give you the last term, right? The 13th term. And they're telling us how many terms to add up. 13 terms. So from 9 to 57, there's a total of 13 numbers that we're going to add up together. But like I said, we don't have to figure out all the missing 11, right? Because we already got the first 2. That we got the 9, and we got the 9 to start off, the 57 to end. But there's 11 more numbers in between. Okay, so let's figure out the sum. Again, we don't have to figure out those numbers in between because we have a formula that helps us do that. So S sub n, I'm just writing it out again. N over 2 times a sub 1 plus a sub n. So, S sub 13. Okay, I'm trying to add up the first 13 terms. So that's going to be 13 over 2. A sub 1 is 9. A sub n is 57. So that's 13 times 9 plus 57, that's 66. Divided by 2, that's 33. Okay, and 13 times 33, what do we get? Anybody ever do it like this? Has anybody ever done that before? You could, right? Just FOIL. So 10 times 30, that's 300. 10 times 3, that's 30. 3 times 30, that's 90. And 3 times 3 is 9. So what is that? 120, so it's 429. I do that sometimes when I'm trying to do big math in my head. I try to break it down into binomial times a binomial. You can do that anytime you want. Okay, or use a calculator. It's so much easier, right? But I'm just doing this by hand. I just decided to go this way. You don't have to do it this way. You could have done 33 times 13 the way we normally do and multiply vertically and all that stuff. Feel free. But I just wanted to show you the use of distribution in a situation that you probably would never do it. So there you go. But yeah, use your calculator. Definitely easier. How do you guys feel about this formula? Not too bad, right? As long as they give you the information you need, it's easy. Okay? Well, what if they don't give us the information we need? So there is an alternate way to find the sum. Okay? And that one involves knowing the common difference, the letter D. Okay, how much it changes by. All right? We need to know n, we need to know a sub 1, and then the letter D. Remember, D is the common difference. Now, sometimes they'll give us the common difference, sometimes they won't. So we'll do a couple where it's given, okay? And then I'll show you one that it's not. And we just got to figure it out. It's not like it's super difficult to do. We just got to figure out what the common difference is and then apply it to the formula. So this formula definitely looks a little bit more difficult, right? But it is derived from the original equation. Okay, and I can show you how that was done after we're done with the examples, because I don't want anybody to feel confused when I show you how they got this equation from the original. So we'll do it at the end. So for example 2, we have an A, B, and a C, but the instructions are the same. Evaluate the arithmetic series. Find the sum, in other words, right? Just add everything up. So they gave me my first term, which is -6. They gave me my common difference, which was 2. And they gave me how many terms they want me to add up. So they're saying, starting with -6, add up 50 total terms. Okay? Based on the fact that every term is growing by 2. So it's -6, -4, -2, 0, 2, 4, 6, 8, 10, 12, etc. Right? Get all those numbers and add them all up. What do they add up to? So we have the formula up on top, so I'm not going to rewrite it. It says S sub 50 equals to 50 divided by 2 times 2 times A sub 1, that's -6, plus 50 minus 1 times D, which is 2. So notice, I'm just plugging in all the numbers. I'm not doing anything special, just plug in the numbers that you're given. 50 divided by 2, that's 25. 2 times -6 is -12. Plus 50 minus 1, that's 49. And 49 times 2, that's 98. All right, so that's 25 times 98 minus 12, that's 86. Okay. Well, you can use your calculator for this too. You can do it, well, I'll show you the old-fashioned way. Another way that you could do this, if you wanted to, you could do like 25 times 90 minus 4. That's 86, right? So you could do it like that too, but we'll just go the old-fashioned way here. So 86, 25, right? This is the way we're used to doing things, usually, right? Unless you guys learn a different way, but this is the way I learned it. So 5 times 6, that's 30. 8 times 5, that's 40, plus 3, that's 43. 2 times 6 is 12. 1 comes up here. And 2 times 8 is 16, and 1 is 17. So 2, you got to add these, right? That's going to be 5, 7, 8, 9, 10, 11. So that's 2,150. Again, with the calculator, it's so much easier. So I don't think you have to do the work on the side all the time. No, if you have a calculator, just use it. It'll be a little easier. All right, so let's take a look at part B here. So I'll rewrite the formula for us. So S sub n is equal to, this is n over 2 times A sub 1 plus n minus 1 times D. So my n value is 25, my D value is 8, my A sub 1 is 20. So I have everything I need. S sub 25 is 25 divided by 2. 2 times A sub 1, which is 20, plus n, which is 25 minus 1 times D, which is 8. Okay, so S sub 25, that's going to be 25 over 2. That doesn't divide nicely, so I'm not going to try to break it down to 12.5. I'll just leave it like that. 2 times 20, that's 40, plus that's 24 times 8. What do I get for 24 times 8? That'd be a 32. So 16, 17, 18, 19, so that's 192. So it's 25 over 2. 192 plus 40, that's 232. And 232 divided by 2 is 116. 116. Yeah. So that's 25 times 116. All right. So again, 116 times 25. We're just going to do, I'm doing it by hand because I don't have my calculator in front of me. So 6 times 5, that's 30. That's going to be an 8. That's a 5. And then move over. 2 times 6, that's 12. That becomes a 1. That's a 3. That's a 2. Add these up. So that's 2,900. So notice so far these two that we did, right, A and B, they're pretty easy. Again, they'd be easier without having to do the work by hand, right? But they're pretty easy. A little calculator will help us get to that end game, the end point a lot quicker. But what if they didn't give you everything you needed? So there's one last example we're going to do where everything isn't just given to you. Okay? So here's what it's going to look like. So this time, they decided that they're going to give us a series, 31, 41, 51, 61. So we know the next one. What's the next number after 61? 71, right? 81. So we know what the first term is, right? A sub 1, bless you, is 31. We know that n is 12, bless you. What's my common difference? It's a plus 10, right? So even though they didn't give me the d value, okay, I could figure out the value for d just by looking at the numbers, right? Saying, okay, it's from this number to this number to this number. It's changing by this much. And once I know the value of d, then I can do the formula, okay? Because I'll know how many terms they want. That has to be given to me. I'll know the first term. That has to be given to me. The only thing they don't have to give me is the value for the letter d. But I can figure that out, right? That's what sections 8.1 and 8.2 were all about, right? Figuring out the common difference. So here we go. Since s sub n is equal to n over 2 times, again, I'm just writing the formula so we have something to look at when we're doing this. So n is 12 over 2. 2 times a sub 1, that's 2 times 31, plus n, which is 12 minus 1 times d, which is, what was it, times d? That's 10. So there you go. So 12 divided by 2, that's 6. 2 times 31, that's 62. 12 minus 1 is 11. 11 times 10. I showed you guys the trick to multiplying times 11, right? But, I mean, you can just do it real quick. I think I showed you guys the trick how to do it in case the numbers were bigger. So we have 110, so put that over here. Whoops. So that's 6 times 172. And 6 times 172, what do we get? 6 times 2, that's a 12. 7 and 6 is 42, so that'd be a 43. So 1032. And that would be your sum.